In this module, we're looking at non-homogeneous linear systems. And we're going to start here with an example which asks us to find a particular solution for this system. X prime is equal to 3x plus 2y plus 3, and y prime is equal to 7x plus 5y plus 2t. Before we proceed with this question, let's be mindful that there are different methods of solving non-homogeneous linear systems within this module. One method is the variation of parameters, but here we're going to use the method of undetermined coefficients because we have constant coefficients. Therefore, if we have constant coefficients, we probably want to use the method of undetermined coefficients. Notice here that we can rewrite our system as follows: that the vector x prime is equal to the 2 by 2 matrix 3, 2 in the first row, 7, 5 in the second row, times vector x plus the column matrix 3 and 2t. All right. We want to observe here that we're going to be selecting a linear substitution trial. Why is that? As we look at these equations, it looks like they're linear. So we'll use a linear substitution trial, which gives us the following system. On the left-hand side of our equation, we have our matrix A sub 1 and A sub 2, which is equal to 3, 2, 7, 5, that's our 2 by 2 matrix, times our vector x, our linear substitution trial of a1t plus b1, and a2 times t plus b2, and as we mentioned, plus our column matrix 3 and 2t. We can do our matrix multiplication on the right hand side, and we can combine like terms, those that have t and those that don't. So we find that our matrix A1, A2 is equal to the 2 by 1 matrix 3 A sub 1 plus 2 A sub 2 in the top row, and 7 times A sub 1 plus 5 times A sub 2 plus 2 in the bottom row, multiplied by t, plus our 2 by 1 matrix, which has 3 times b1 plus 2 times b sub 2 plus 3, and in our second row, 7 times b sub 1 plus 5 times b sub 2. Now might be a good time to pause the video and make sure that your matrix multiplication is up to par. All right, so we have now our equation here, and we're going to equate the coefficients to give us 4 individual equations. The first one being 3 times a sub 1 plus 2 times a sub 2 is equal to 0. The second equation, 7 times a sub 1 plus 5 times a sub 2 plus 2 is equal to 0. The third one, 3 times b sub 1 plus 2 times b sub 2 plus 3 is equal to a sub 1. And finally, 7 times b sub 1 plus 5 times b sub 2 is equal to a sub 2. With these 4 equations, we can take the first two, and by using elimination, we can find that a sub 1 is equal to 4 and a sub 2 is equal to negative 6. Again, we haven't shown the work here, but you know how to solve a system with 2 equations. But if you wanted to practice or verify that this is indeed correct, now would be a good time to pause the video. Now that we found a sub 1 and a sub 2, we can use substitution of these values and substitute them into the last 2 equations, giving us that b sub 1 is equal to 17 and b sub 2 is equal to negative 25. Thus, we now have our particular solution. And that would be x sub 1 of t is equal to 4t plus 17, and x sub 2 of t is equal to negative 6 times t minus 25. These questions are going to take a little bit of time, and we're going to need to be very careful on our algebra here that we're not making algebraic mistakes. But if you should run into any difficulties, we'll look for questions that you might have on the discussion board.